Hello, my name is Peyton Schaefer, and I will be doing the code review for the first homework, which is matrix multiplication with Pthreads. So the program description is that this program is going to ask the user for the size of two matrices, fill them with random numbers, and then do the matrix multiplication using Pthreads, where each thread will take control of the dot product for the cell in the solution matrix, which will take obviously the row from the first matrix and the column from the second matrix. So I included the IO stream, which is the standard IO library, the STD library, which is just a standard library. This is for my random numbers. And then the C time library. This is for seeding the random number generator. And then, of course, the pthread library, which is going to be to actually call the threads. And then I'm going to be using namespace STD throughout the code. So the first global variables are going to be a 2D pointer array for the three matrices. A is going to be matrix 1, B will be matrix 2, and then C is the solution matrix of A times B. And then I also created this structure, and it's going to be a structure for the parameters that will be passed to the dot product function. So it's going to consist of I, which is going to be the row position of the cell for the solution matrix, J, which will be the column position for the cell of the solution matrix, and then N, which is going to be how many components are in the vectors. So like if we're doing the dot product, like how many components are in those two vectors that we're doing the dot product. So it's going to be either like if they're the same number, so it'll be like the row of the second matrix and the column of the first matrix are the same number. So the first function that I created is a create matrix function. So this is just creating the arrays, the 2D arrays for the matrices. So we create this 2D array and then we go through a loop and then create an array for each pointer. So we have a 2D array of pointers for integers. And then we return the array at the end. So the next function, we have the fill matrix function. So this function takes the matrix and its size and then goes through each position in the matrix and then adds a random number. So this rand function is what gives us the random number. And then we mod it by 100 and add 1 so we can get numbers from 1 to 100. So the next function that I have is the print matrix function that'll take an array and the size in rows and columns. And then it's going to loop through each cell of the array and then print that number at the cell. And then of course, at the end of each row, we do a little end line so we can come down so it'll look nice. And then the last function that I wrote is my dot product function. So this is the function that is actually given to the pthreads to, so when we do the matrix multiplication. So the first thing that it does is it takes the parameters and we're going to just cast the type of params onto the arguments that we have so we can know what it is. And then we're going to unpack those parameters from our struct and we get I, J, and N. They represent the same values. So of course, I is the row position, J is the column position, and N is how many components are in the vectors. So I then just to be sure initially set that position to 0 in our solution matrix. And then we are going to loop through each component of the vectors that we're doing the dot product on, and we'll be adding them up to the total sum for that, because the dot product, of course, is the components from the same like position multiplied by each other, and then they're all added up. So this K incremented is going to increment the column position for A, so we can go through that whole row, and it'll increment the row position for B, so we can go through that whole column. And then we'll add them all up and set it to Cij. And at the end, we call pthread exit so that we can exit the thread. So lastly is the main function or main. So the first thing we do is we create this seeds or random number generator. So we can get a different random number every time. And the seed that we give it is just the current time. So this is why we have that seed time library. Next, I initialize the rows and column size for both of the matrices. Column 1 and row 1 are for matrix 1. Row 2 and column 2 are for matrix 2. So then a little just welcome message. So then I have this do while loop that will continue to ask the user to input the size of the matrices. So it first asks for the size of matrix one, the rows and columns with a space between them, and then matrix two. And then lastly, we do a check to make sure that the columns of matrix one equals the rows of matrix two, because that is a condition to do matrix multiplication. So if it passes that, we keep going, and if not, we print out this statement. That's just a reminder of why that they have to redo it again. And then they go back through and have to input the size again to make sure that it works. So next, I called my create matrix function on all three matrices, A, B, and C. So this is just so we have that memory allocated. And then I filled matrix A and B with the fill matrix function that we talked about earlier. This fills matrix A and B with all the random numbers that are needed. So then I print out matrix A and B just so the user is able to see them and make sure it looks nice. So it's going to print out matrix one, and then the row one by column one, and then the actual matrix and the numbers, and then the same thing for matrix two. So after that, I then created this Pthread threads. So this is my 2D array of threads for each cell in the solution matrix. So then this for loop then is like initiating and creating all of the threads. So we set the parameters correctly for the threads. So giving the right row and right column of the solution matrix. And then of course the size of the components and the vectors for the dot product. And then we create the thread, giving it a reference to the thread that it represents in this Pthread 2D array. And then we give it our dot product function, and then these are our parameters that we are also passing. So then next, after we create all the threads, we need to make sure they all join and get synchronized, so we're not ending the program before it's all done. So this for loop here goes through all of the threads that we created and make sure they're all joined up, and they will wait for each other, and they will all finish together. And then lastly, we just print out the solution matrix using our print matrix function, just like we did for the A and B matrix. So that is all the code. Now I will give you a little demo. So first, let's just make sure it compiles. So we have the G++ compiler, -o, our output file, and our actual C++ file. So we'll run that, and we see that it compiles fine. So now I'm going to run the matrix multiplication program. So it says welcome. So a reminder, the columns of matrix one must equal the columns of matrix two. So let's try, I don't know, 4 rows equals 4, columns will be 5. And then just to make sure that our check works, we're going to try 8 and 5. So this should give us a no. Yep, we're not allowed to keep going. So we must try again. So this time we're going to do 4, 5, and then since the columns of matrix one have to equal the rows of matrix two, we'll do 5 and then maybe 7. So then we press enter. We're given matrix one and matrix two, both filled with random numbers from 1 to 100, and then we're given our solution matrix. I'll do another one with a smaller size for the matrix. So let's do 2 and 3, 3 and 2. So this is my program fully working. As you can see, it works for these. And yeah, so thank you.